Hello everyone and welcome to another video of Matukulasan. In this video, we will talk about permutation, including circular and repeated. But before we begin, make sure that you have learned about the basic counting principle or the multiplication rule for easy understanding. Let us consider the possible arrangements of the letters A, B, and C. So we can list them all here. And let's start with ABC, followed by ACB, or it could be BAC or BCA. And if C will come first, we have CAB, and finally CBA. So these are the six possible arrangements for the letters A, B, and C. Remember, the arrangement here is important, and this is called permutation. So a permutation is an arrangement of n distinct objects in a specific order. So remember, in a permutation, the arrangement is important. So AB is different from BA. Now, for us to easily compute for permutations, we actually have a formula for it, written as NPR, wherein N is the number of objects and R is the objects that we take at a time. Or this is equal to N factorial divided by N minus R factorial. So remember, factorial means just the arrangement of descending numbers multiplied together. So if we have 5 factorial, it means 5 times 4 times 3 times 2 times 1. Or if you have 3 factorial, it means 3 times 2 times 1. And if it's 0 factorial, that is still equal to 1. So if we have 5p2, it means 5 factorial divided by 5 minus 2 factorial. Just substituting the values of n and r in the formula. So here we have 5 factorial divided by 5 minus 2 is 3. So this becomes 3 factorial. Now we all know that 5 factorial can be written as 5 times 4 times 3 factorial. Dividing it by 3 factorial, we have 1 here. So 5 times 4 times 1 is 20. So 5p2 is 20. We can actually use a calculator to compute for the value of NPR. So if you have a scientific calculator, you just have to look for the formula NPR. In this case, it's above multiplication. So for us to compute for 5p2, just need to press 5 in your calculator, shift for the second floor, and wait for the p to come out. Now it's 5p2, so place 2 here, equal sign, and the answer is 20. Let's have an example. Find the number of 5 permutations of a set with 9 elements. So the n here is 9 because these are the number of choices that we have. While we need to take r or 5 permutations or number of objects at a time. So in this case, for the formula, it's 9p5. Using the formula, we'll have 9 factorial divided by 9 minus 5 factorial. This is equal to 9 factorial divided by 9 minus 5, which is 4 factorial. And you can rewrite 9 factorial to 9 times 8 times 7 times 6 times 5. Stop with 4 factorial and 4 factorial below. So we stop with 4 factorial here so that we could divide it and be equal to 1. So 9 times 8 times 7 times 6 times 5 is equal to 15,120. And of course, we can check our answer by using a calculator. So 9p5, the answer is 15,120. Let's have another example. How many different ways can a coach and an assistant coach be selected for a high school basketball team if there are 8 applicants? Remember that before you use permutation, you need to make sure that the arrangement is important. So changing the places is significant. So for example, if person A will become the coach and person B will become the assistant coach, then the arrangement BA would also be different, right? Because they're two different persons. So here we can use permutation because changing the persons in charge per position is different. So here we have 8 applicants, so we have n equals 8. While we need to choose 2 persons for the 2 positions, so R is equal to 2. So the solution here using permutation is 8p2. Using the formula, we have 8 factorial, 8 minus 2 factorial. So this is equal to 8 factorial, as we all know, is just 8 factorial, okay? So 8 minus 2 is 6 factorial. So rewrite 8 factorial to 8 times 7 times 6 factorial. So we stop with 6 factorial so that we could cancel this out for it to become 1. And 8 times 7, as we all know, is 56. So there are 56 possible ways for us to choose the position of 8 persons to 2 available positions. For this example, we need to find out how many different ways can 4 books be arranged on a shelf if they can be selected from 7 books. So, as we all know, the arrangement of books here is important. So, if, say, this is book 1 and this as book 2, we all know that interchanging the position of these 2 books is a different arrangement. So, here we can use permutation. So we just need to identify n, and in this case, our number of choices is 7. So n is equal to 7. While we need to arrange them in 4 different orders. So R is 4. So solving for 7p4 or p4 will give us 7 factorial divided by 7 minus 4 factorial is equal to, as we all know, just need to copy that first. 7 minus 4 is 3 factorial. So 7 times 6 times 5 times 4. You stop with 3 factorial divided by 3 factorial. Cancel this out. So 7 times 6 times 5 times 4 times 1 is equal to 840. A canned good food company decides to test market a product in 7 areas. So how many different ways can 3 areas be selected in a certain order for the first test? So it says here a certain order, so the arrangement is important. So it's different if you're going to choose area 1 and area 2 versus area 2 and area 1. So identifying the choices, we have n here, which is 7, and r, which is equal to 3. So all we need to do is to compute for 7, p, 3. And using our calculator here, we have 7, p, 3. That is equivalent to 210. So we have 7p3 equivalent to 210. So there are 210 ways where a specific employee can go around the 7 areas or 3 areas at the same time. In how many ways can we select 4 students from a group of 6 students to stand in line for a picture? So we have 2 questions here. So let's take the first one as A. So we need to select 4 students from 6 students. Is the order important when they are in a line for a picture? Yes, definitely. So this is 6P4 because R is 4 and we need to choose from 6 students. So N is equal to 6. Using your calculator, 6P4 is equivalent to 360. So we have 360 ways. Now for the second question, in how many ways can we arrange all 6 of these students in a line for a picture? So please don't get confused because we just need to select all 6, right? From the choice of 6 students. So meaning N here is equal to 6 and R is also equal to 6 because we need to choose them or choose those 6 students at the same time. So we have 6P 6. By using the formula, we have 6 factorial divided by 6 minus 6 factorial. That is equal to 6 factorial divided by 6 minus 6 is 0 factorial. We all know a while ago that 0 factorial is 1. So 6 factorial. You can also use your calculator to solve for 6 factorial. So let's try doing that here. 6 factorial. So you just have to look for the factorial symbol. In my calculator, the factorial symbol is above this key. So shift this key, I have factorial. So the answer is 720 ways. So the answer here is 720. You can actually verify it using the 6P6 here on your calculator. So we have 6 shift P and then 6 here will also give you 720. So from this example, we have found out that if R is equal to N, then we have NPN, right? And NPN is just equal to N factorial. Or if it's R, then RPR is just still equal to R factorial. In this example, how many ways are there to select a first prize winner, a second prize winner, and a third prize winner from 20 different people who have entered a contest? So, if we're talking about the 3 places, the arrangement is important because if person o, person A will win the first prize, then it's different if the person B will win. So the arrangement is important. We can use permutation. So the formula, n is equal to 20. And since we have 3 places, r is equal to 3. So we have now 20p3. And by using your calculator, the answer is 6,840. So there are 6,800 840 ways to choose the winner. Now, this example is tricky. How many permutations of the letters A, B, C, D, E, F, G, H contain the string AB? So when you say string, it's just the list of code that we write for a certain arrangement or combination. So in this case, notice that we could rearrange any of these letters, right? But A, B always go together. So for example, the arrangement could be AB first, then followed by C, D. You can actually interchange these letters any way we want, right? So we only had 1, 2, 3, 4, 5. 6, 7. We just need to arrange 7 instead of 8 letters. So by counting principle, we just need to multiply each of the representation of this letter. So for the first position, we have 7. And if AB was already chosen, of course, we can no longer choose it here. So we have choice of 6, 5, 4, 3, 2, and 1, which is actually just equal to 7 factorial. Because remember, you can always rearrange these letters except for AB, which could be here, but will only be counted as one arrangement. So we call this here block because they always go together. So the usual counting technique that you could use here is the formula 8 factorial, right? Because we have 8 letters. But since these two always go together, it became 7 minus 1. Or I mean 7 factorial. Now, using the permutation formula, instead of using counting technique like this one, you can actually use 7p7 because we have 7 options that we need to arrange at the same time. So taken 7 at a time. So 7 options, taken 7 at a time. And as we all know, in the previous example, 7p7 is just still equal to 7 factorial. And 7 factorial is equal to 5040. So there are 7 or 5040 ways for you to rearrange these letters where A, B always go together. This example is also tricky. The number of three-digit telephone numbers having at least one of their digits repeated is how many? So in this example, we need to identify codes like 213 using 10 digits that is from 0 to 9. So as we can see here, arrangement is important, so permutation is involved. And another thing is we need to make sure that one of the digits that was used should be repeated. Okay, so it could be 221 because 2 is repeated. It could be 445 because 4 is repeated. But we cannot use 213 because there's no repetition here. Okay, you can also use 333 as long as there is at least one repetition. Okay, and it would be difficult for us to identify or have a solution for this one if we will not identify all the possible arrangements first and then just subtract it from the arrangements where no digits are being repeated. Well, let me just show it to you. So by counting principle, we need to first identify all the possible combinations. And that is possible if repetitions is allowed, okay? Or repetitions are allowed. So we have 10 times 10 times 10 because we have 3 codes and we have a choice of 10 digits per code. So 10, 10, and 10. Okay? So this is all arrangements, all possible arrangements. Okay. Now, how about we identify those without repetitions? That is permutation, right? So out of 10, okay, we need to take 3 at a time, and that is 10p3. And meaning we are identifying all the possible combinations without repetitions, correct? So all we have to do now is to subtract this. Oh, does it look like subtraction? So how about we put it in the middle? Let me just take a note. So this is without, oops, that is without repetitions. That is permutation, right? So if we were going to subtract all the all the arrangements without repetitions from the arrangements of all possible arrangements in the the given problem, then we could get what? We could get all the numbers with at least one of their digits repeated. Okay, so that is 10 times 10 times 10, so that is 1000 minus 10p3 on your calculator is 720. So 1000 minus 720 is 280. So we have 280 ways to arrange different digits, making sure that at least one of their digits is repeated. Now, what if there is a repeated object in the given? So say in the choice where the choices are A, B, and C. So if we're going to rearrange this A, B, C to say interchanging these two, it's just the same arrangement, right? Even though you literally interchange these two letter A's. So if that's the case, we are like counting the same arrangement twice. That is why we have a division rule here, that for the n number of objects, you just have to divide it with the number of times an object is repeated, multiplied by the other factors or repeated objects that you could identify. Now, how about we just give an example? How many ways can you arrange the letters of the word Ampalaya? So, as you can see here, if these letters will be rearranged, interchanging A doesn't make sense because you will count it twice. So here, there is repetition, right? So first, we need to identify all the possible letters here. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 options. While listing those with repetitions will give us. So here we have how many A's? 1, 2, 3, 4. So say n sub 1 is 4. And what are the other letters? We have M. And we all know M doesn't have a pair. So just one M. Okay, so all you have to do is to list all the possible letters, and if it's repeated, just count it. Okay, and write it here. So here P is not repeated, so it's also 1. L is also not repeated, so this is 1. Y is not repeated, so n sub 5 is equal to 1. So following the formula, we have 8 factorial, that is n. And then all the repetitions are n. We have 4 factorial, 1 factorial, and 1 factorial here, 1 factorial there, and one more 1 factorial. Now, as we all know, these are all just equal to 1, right? So we just have 8 factorial divided by 4 factorial. So following the formula, we have 8 times 7 times 6 times 5 times 4 factorial. Then 4 factorial here. This will become 1. So 8 times 7 times 6 times 5 is equal to 1680. We can also do it in our calculator. So if it's 8 factorial, just divide it here, 4 factorial. So that is correct. It's 1680. Here's another example. How many 6-digit numbers can be formed with the numbers 1, 3, 3, 3, 4, 4? So there is repetition here. So to save time, just count the number of objects that we have. So we have 1, 2, 3, 4, 5, 6. So that is 6 factorial. Okay. Divided by 3 is repeated twice. So that's 3. And then 4 is repeated twice. So that's 2. So we just have to ignore all the objects that were counted just once. So that is to save time, of course. So 3 factorial Then we have 2 factorial here. Now remember that if you're plugging this on your calculator, make sure to involve the multiplication symbol because it might tell you that there's a syntax error. So we have 6 factorial there, we have 6 factorial, or just rewrite 6 factorial to 6 times 5 times 4 times 3 factorial. 3 factorial divided by 2 factorial, this will just become 1. 6 times 5 times 4 is what? It's 120. Okay, divided by 2 factorial. That 2 factorial is just 2 times 1, so that's 2. So the answer here is 60. So we have 60 ways to arrange this digits. Okay, so it's a 6-digit number, so it could be 133,344, or it could be 443,331 and whatnot. So if you're gonna plug it on your calculator, it should be 6 factorial, okay, divided by, open parentheses to group the denominator. So that's 3 factorial, right? Don't forget the multiplication symbol. 2 factorial, close parentheses, equal sign. So that is 60. So correct. If a coin is tossed 6 times, how many different outcomes consisting of 4 heads and 2 tails are there? All right, so here 6 times. So all in all, we have 6 possible places for the outcomes or arrangements. So we have 4 heads here, so meaning we have 1, 2, 3, 4 heads, and then 2 tails. So this arrangement could be H, H, T, T, H, H. So this is one of the possible arrangements because it should just consist of 4 heads and 2 tails. And as we all know, even if you will interchange one of these H or T's, it's just the same. So there's a repetition here. But again, the order is still important. So here, to save time, identify the n, or the number of options that we have. So that is n, 6. So 6 factorial divided by 4 heads, meaning those are the 4 repeated objects. That's 4 factorial. Times, we have here 2 tails. That is equivalent to 2 factorial. So solve it again. 6 factorial can be written as 6 times 5 times 4 factorial. 4 factorial times 2 factorial. This will just become 1. And then 6 times 5 is 30 divided by 2 factorial, which is just equal to 2. So 30 divided by 2 is 15. So we have 15 ways to show the different arrangements of the outcomes for tossing 6, or I mean, for tossing the coin 6 times. A ship must raise 9 flags at one time. So the flags are consist of 2 reds, 3 whites, and 4 green. Now, how many different flag combinations can be raised at a time? Please don't be confused because the word combination here was used, but since that's a different lesson, you might actually interchange the two, permutation and combination. So what we are just after are the arrangement of the flags. So if the red will be placed in front and white will be placed at the last file, then it's a different thing if these two will be interchanged. So still, the arrangement here is important. Okay. But there are some repetitions. We all know that there are 2 red flags, 3 white flags, and 4 green flags. So all in all, n here is equal to what? You just have to count them, right? So 2 plus 3 white plus 4 greens. We have 4 plus 3, 7 plus 2, that's 9. So all in all, n is equal to 9. So using the formula, we have 9 factorial divided by 2 red, so that's 2 factorial, 2 repetitions there. And then 3 white, that's 3 factorial, times 4 green flags, so we have 4 factorial there. Okay, so by computation, or using your calculator, the answer is 1260. So there are 1260 ways to raise them at the same time, and of course with different arrangements. Now let's talk of a different kind of permutation. It's called circular permutation because if the objects are arranged in a circular manner, then the positioning might differ. So for example, we have three persons that will sit on the table, on a circular table. So say this is person A, this be person B, and this as person C. So notice that the arrangement is, if we're going to arrange them clockwise, that's ABC. This is arrangement ABC. So notice that if A will be seated in the position of B, so is A is coming here, let's just place A here, and B will replace C, and C will replace A. Then did the arrangement change? Actually not, because the positioning of A here doesn't affect the positioning of the others as long as the arrangement is like that. So still have A, B, C here. So even if A will sit here and B will sit beside him on her or in his left, then it's just the same arrangement. That is why the formula is subtracted to 1. Okay, removing all the possible overlapping arrangements. So that is n minus 1 factorial. Let's have an example. In how many different ways can 5 people be seated at a circular table? All right. So there are 5 people here, so n is equal to 5. And since they are arranged in a circular table, we're going to use the circular permutation rule. So n minus 1 factorial. So 5 minus 1 factorial is equal to 5 minus 1 is 4, so 4 factorial. And 4 factorial is equal to 24. So there are 24 ways for us to arrange these 5 people in a circular table. Now, how about this example? In how many ways can 5 couples be seated at a round table if the men and women want to sit alternately? So we have established in the previous example that the first position, okay, will not actually affect the remaining arrangements, right? So for example, here we have 5 couples. So if they are 5 couples of men and women, we have 10 persons, right? So let's count the seats. So this is for chair 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I did not just arrange them circularly, okay, but I hope you get it that we have 10 seats, right? So if the first person will sit here, it must be a man, right? Because the arrangement should be alternate. So man, women. So say man, women here. Then man, women, man, women. Oops. This is women, man, women, men, and women. Okay. So say the first man will sit here. That is just how many arrangement? That's just one. That's just taken as one, right? So there are 5 men, remember. So the first one will sit here. And that is only one arrangement because if it's circular, okay, the arrangement of this first person will not actually change the arrangement of the whole set. So how many women left? There are still 5 women, right? Remember that they're couples, so we all actually have 10 persons, 5 men and 5 women. So we have 5 women here. Okay. So again, man will sit here, but remember that one of the men already sat here. So 5 minus 1, that's 4 remaining men. Okay. And the first woman sat here, so we only have 4 women here. Okay. For the men, this is for a while ago, but since the first two already sat, okay, We only have 3 here. For the women, 4 sat here, so this will also be 3. And then man, after the 3 sat, we only have 2 options left. And then for the woman, same. And then for the man, 1 here, okay, because 4 already sat. And then for the woman, 1 also, because the other 4 already sat. So by multiplication rule, okay, you just have to multiply these values for you to get the answer, which is 2,880. So we have 2,880 ways to arrange the 5 couples alternately. And that's all for this video. So if ever you are still confused about the counting techniques or the multiplication rules that I mentioned, make sure to check my other video about basic counting principle or the multiplication rule. And also, if you want to learn if how many ways you can actually arrange objects where the positions or the arrangement is not that important, then you must watch the lesson about combinations. See you in the next video.